Hi, welcome to Train Signal and the continuation of the Advanced Features in Windows Server 2012 course. Continuing our discussion of network load balancing, we're going to discuss the idea of PowerShell-based administration of this important feature. PowerShell support underlies most of what you can do in Windows Server 2012. Really, that was largely true in Server 28R2, but really in Server 2012, Microsoft has really taken the PowerShell administration idea to heart. They've embedded it in just about anything that you can do in the Windows Server 2012 operating system. Network load balancing is certainly no exception to that rule, so we're going to explore PowerShell integration with NLB in this lesson. So to start this off properly, we're going to put our attention on PowerShell proper. There may be some of you who are unfamiliar with PowerShell. I've used a little bit of it here and there in some of my demonstrations in some of the other lessons, but I do want to focus on it specifically here to lay the foundation for actually doing administration of NLB with PowerShell. PowerShell is a feature of everything Windows Server 2008R2 and later. It could be installed onto earlier OSs, but it was the Server 2008R2 OS on the server side, Windows 7 on the client, that embedded PowerShell for the first time. And what it is a command line scripting environment. In that sense, it's somewhat like cmd.exe. Some of you have used the cmd command prompt to get things done, and indeed that's a great way to get a number of things done. If I want to copy files from one spot to another, in some cases, there are some people who are more comfortable at the command line than even using the point-and-click features of a GUI. There are a number of tasks where I don't want to have to be at a GUI to perform certain kinds of tasks. I'd rather write a script that will run in the middle of the night and perform some task for me so I don't have to be there pointing and clicking my way through making something happen. And I would like to be able to have that same kind of command line scriptable interaction for every part of Windows that I might choose to administer. And PowerShell delivers on that promise. It gives us a technique to be able to perform almost anything that we can think of anywhere in Windows Server 2012 using the same consistent command line environment. Some of you are aware that Microsoft has built command line tools to help with various aspects of Windows Server administration for a long time. What's interesting is that those different command line tools historically have been developed by different developers in different parts of the company who didn't necessarily talk with each other or agree upon standards for how command line tools work. So you'll see some tools where you'll type the name of the command and then to be able to calibrate its behavior use a hyphen and something to be able to tell it to do something different. But others don't do that. They use a slash and something. Other tools use a totally different approach where you type the name of the tool and then suddenly you're inside of it and you type other special keywords and that drops you into different logical contexts inside of that tool where other unique commands are available. And there's no dashes or slashes at all. Can be awfully confusing. PowerShell integrates all of that, giving us one consistent way of doing everything that we might do, with a naming structure for the commands that we use that is designed to be easy to understand and absorb. It covers Windows, again, almost entirely in Windows Server 2012. And, interestingly, provides support for other software development environments that are non-Microsoft based. Some of you might be familiar with the VMware family of virtualization products. Turns out that VMware has support for something they call PowerCLI, the PowerShell command line interface. PowerCLI is a PowerShell-driven environment for administering VMware. The NetApp SAN storage environment has a module for PowerShell. There's an increasing number of areas of administration, even outside of Microsoft's own purview, where PowerShell is a useful tool in the hands of somebody who wants to be able to automate certain kinds of tasks. Let's take a quick look at some simple PowerShell functionality before we tie it back into network load balancing in particular. But once we do, we'll see that there is a whole host of network load balancing command line features that we'll explore in our Windows environment. So let me jump over to Server 1 and we'll do a little bit of quick PowerShell getting to know you demonstration, and then we'll actually apply it to some of these NLB commands that you see named here. So here's a typical PowerShell window. You may have noticed that Microsoft likes PowerShell so much that they made it the second button here on the taskbar next to the Server Manager tool right before Windows Explorer. So Microsoft really intends for this to be a very practical, very well-used tool in the hands of a system administrator. Well, what's something that I might want to do with a Windows computer? I might want to learn what programs are running on it. Well, how do I know what command to use? There's a command for that. It's called get-command. The get command tool brings up a list of all the commands that the system currently knows how to run. And we can see that at the moment it's quite some healthy long number of them. Okay, so now what do I want to do? I want to be able to do something with programs. I want to get information about a running process. Well, I can go get commands that contain the word process in them somewhere. And there's one called get-process, designed, as you might well imagine, for retrieving information about running programs. So let me try that. Get-process. Hey, there we go. We got a list of information about processes, about programs available that are currently running on this computer. If I want to learn more about the way the DNS server is behaving, I could go get-process DNS and get that set of information about the DNS server. Now what we're looking at there is a formatted version of the data that actually came out of the call to get-process. PowerShell has some built-in formatting to display data in ways that seem sensible to it, to not intimidate people with just too much data. If I want to know more about what DNS is doing, there's actually more data available coming out of that get-process command than I'm actually seeing here in this set of output. To see all of it, I can get that process information again and format a list of those pieces of data that I want to see. Well, I don't know which pieces of data that I want to see, so I'll say let's just show me all of them. Format list star. And there's everything there is to know, according to PowerShell, about the execution of the DNS server service. I can see how many handles that process is holding. I can see what version of the file it's executing. I can see who wrote it. Somebody called Microsoft Corporation. Okay, that's not surprising. Amount of memory being consumed. Total amount of CPU time that's been consumed by that process. Looks like 20 seconds since I started this thing up, whenever that was ago. So a lot of information at my disposal. Some processes I might not want to run anymore. I might want to call the stop-process commandlet to be able to bring those things to a halt. Let me start a process so that I can kill it. Our good friend Notepad is going to be my crash test dummy. There it is. I can go get process information about a process called Notepad. And what I would like to do is to be able to stop that process. And there's a commandlet out there called stop-process. How did I know that? I could have consulted my get command list and see, aha, look, stop-process. I bet you that stops processes. Now, what I would want to do in some cases is just to say stop-process and then maybe name the process. Well, it turns out this isn't going to succeed. If I say stop-process Notepad, PowerShell throws a fit. It says, well, wait a minute, no, I can't figure out how to do what you're doing. Can't convert the Notepad value of type system.string to type system.diagnostics.process. It says, I can't seem to make what you gave me fit in the way that I'm designed to work. And that brings forward the obvious question, how is it supposed to work? Well, fortunately, that ability to learn how PowerShell works is in PowerShell. I can issue a help request on any PowerShell statement, like stop-process, and get information about how it behaves. And I can see that I can stop processes by supplying an ID number, and that works. I don't see a way to just supply a process name and have it get terminated because of the name of that process. So I need that ID number. That's one way to do it. Or we can see that I can supply an input object of a process or a collection of processes. That's what the square brackets are telling me. If I could somehow get my hands on the process that I wanted to stop and somehow feed it to stop-process, this tool seems to believe that it's willing to stop the process that has that identity. That's kind of a neat idea. Do I have a way to be able to get information about a process? Well, I do. That's get-process. Stop-process wants to stop the process. How do I hook the two together? That hooking up process is referred to as pipelining. I can get the process called Notepad, and I can pipe all the information about it to stop-process. And when I do, stop-process receives all the information about the process coming from get-process, and, keep your eyes on the Notepad window, kills Notepad. It did exactly what I wanted it to do. Now, I've only just scratched the surface of PowerShell functionality. We have a whole separate course here at Training Signal that discusses PowerShell. Come on back and take that. That's a lot of fun. Get used to using PowerShell. You're going to see it all over the place in Windows Server Administration and Server 2012. So, let's let's actually take this idea and apply it specifically to network load balancing. Let me go clear my screen so we have a fresh, clean slate with which to start exploring. Now, how does PowerShell know how network load balancing works? The way that it accomplishes that is through what's referred to as a module. PowerShell knows basic things about running processes, about manipulating files, things of that sort. Those things happen kind of instinctively for PowerShell. PowerShell knows about that no matter what. Beyond that, depending upon which software is installed on your computer, you may have the ability to direct PowerShell to learn about and work with additional kinds of information about your computer. I can, in other words, install a module. I can supply a plugin of a sort to PowerShell to tell it how some piece of software works. Specifically, there is a module at our disposal here that I'm going to import called Network Load Balancing Clusters. It's an awful mouthful. Now, how did I type it that fast? I didn't. I used something called tab completion. PowerShell in version 3 is smart enough to look through the whole list of modules in my computer, find the one that starts with a couple of letters that I started typing, and fill the rest of them in for me. I'll use that idea a couple more times as we work our way through. So, if I import the Network Load Balancing Clusters module, this PowerShell window now knows how to speak cluster, for lack of a better word. The way that that got there, incidentally, was because I installed the client components for network load balancing management on this computer. Let me go explore my Add Roles and Features window. Here in the Features area, we can see that we have no copy of network load balancing currently on server 1. I've got it running over on servers 2 and 3. But I do have here remote server administration tools for doing feature administration, and I do have the network load balancing tools, which includes the NLB snap-in, the GUI for doing manipulation of network load balancing, and the NLB module for PowerShell. So anywhere that I've got the GUI, I've also got the command line functionality of PowerShell, at least if I'm running Server 2012. So let's actually see that in action. I've imported that module. That means that get-command is now able to show me a much longer list of commandlets than what we saw a moment ago. But I don't want to see that whole list. That's a lot. Can I narrow it down? Well, yes, of course I can. I can say get-command -module network load balancing clusters. And it'll show me just the commands that are relevant for NLB. I like to look for the things that I can get information about as a good starting point. And I can get information about NLB clusters, about the nodes of those clusters, about the port rules that govern the behavior of traffic to those clusters. I can undo those things. I can remove those objects. I can set their properties. I can start and stop clusters and their nodes. I can suspend and resume. Neat. I can add new port rules and things of that sort, disabling and enabling rules as need be. Very good. So I've got quite a rich set of functionality to manipulate NLB. So what I want to do is I'm going to perform the process of creating and managing an NLB environment entirely from the command line. For illustration purposes, I will also keep the NLB GUI up over here and be able to jump back and forth to just illustrate that the things that I'm doing in the command prompt have a direct, immediate, and verifiable impact on the NLB cluster as a whole. So step one would be to actually go ahead and build an NLB cluster. Let me clear my screen and we'll take it from the top here. New-NLB cluster is the very logical command to be able to create a new cluster using network load balancing. When I do that, I need to identify the name of the host on which I want to initially create the cluster. Host name here is going to be the name of a particular server that's part of my NLB cluster. Let me take NYC server 2 for that. Next important question is which network interface is the one that we're going to be building this upon. Remember that you get your choice of which of potentially several NICs on that server is the one that you want to expose as the network load balancing adapter. In this case, we've got one whose name is Ethernet, so I'm going to use that one. we need to identify what the cluster's IP address is going to be. Cluster primary IP is the name of that particular parameter, and I'm going to set it at 172.18.38.200. Beyond that, we need to identify the cluster's name, and I'm going to call it NLB Cluster 1. And I do want to set this to use an operation mode of multicast. Now watch this. Want to see something fun? Tab, tab, tab. I didn't type anything there. This is a neat new feature of PowerShell version 3. If the value of a parameter, if the set of values appropriate for some parameter that you want to use are defined in what PowerShell refers to as an enumeration, you can simply tab to cycle through that list of values without having to type in any of the characters. That's kind of fun. So, operation mode multicast, that looks good. I'm going to hit the enter key. System's going to think for a few moments, and it will have built me an NLB cluster. There we go. That looks good. Can I confirm that in the GUI? Sure. We go right-click Network Load Balancing Clusters and connect to an existing cluster that I anticipate is residing at NYC-SVR2. Hey look, I see a cluster. Its name is NLB Cluster 1. Its cluster IP address is 38.200. It's using its Ethernet interface. Looks good. This looks just like what we saw when using the GUI to be able to create these things in the past. This cluster does have a default cluster rule in which all 65,536 possible ports are being routed using multiple host routing using single affinity. Alright, can I customize the cluster now that I've got it? Well, sure I can. Maybe I want to add an additional node to the cluster. It's not much of a cluster if it only has one computer in it. Let me plan to add an NLB cluster node. Tab completion is your friend, as you can see. I need to identify which computer is going to be joining the party here, and I need to identify where I'm making this configuration take effect. Now, I only have the one host, NYC Server 2, that is part of the cluster. The work that I'm doing here is on Server 1. When you're trying to administer a NLB cluster that's out there somewhere, in other words, where your administration tool is not on one of the clustered nodes itself, you need to identify where the command you're running is going to be executed with the -hostname parameter. And in this case, I'm going to target NYC Server 2. It's my only cluster node. But of course, Server 1 can't have any way of knowing that without me telling it. I want to make a configuration change by way of the interface on that server called Ethernet. And I want to be able to create a new node. That new node has a new node name of NYC-Server 3. And we need to identify which interface on that new node interface. Let me stretch this so we can read it. There we go. New node interface on NYC Server 3 is named Ethernet as well. There we go. The state of that node is converged, which is to say it's happy. It has made nice with the other members of the cluster. Note that the NLB Manager GUI doesn't immediately update to reflect that change. I need to go highlight it and press an F5 to refresh. Hey look, there's another server, NYC Server 3. Cool. That's good. So, now that we've built a cluster, it's got two servers in it, Server 2, Server 3. If I want to get some information about it, I might go get information about my NLB cluster. If I just say NLB cluster, get-NLB, it looks for it locally on the computer that I'm currently on. Server 1 doesn't have an NLB cluster. So, it says, hey, invalid namespace. That doesn't make sense. When you see that, you need the host name of one of the computers that is in the cluster to be able to access the data. The data that describes the way the cluster behaves really is in the servers that are running the NLB service itself, not on the computer that's running the NLB Manager client. All that tool does is connect to some server in the cluster and retrieve information from the servers that actually know what's going on. So let me connect to NYC Server 2. Nothing special about Server 2. I could equally as well use Server 3. And I can see that Server 2 is a member of a cluster called NLB Cluster. It has an IP address, has a subnet mask, uses the multicast mode for communication. If I want to get more information about it, remember that PowerShell by default only shows you the things that the developer of that particular module thought would make sense for you. I can take that object and pipe it to format-list star. I can see the remaining details. I can see the cluster MAC address there. Neat. Having done that, I might ask the question, okay, how many nodes have I got in this cluster? I might take the node and pipe the information about the node to get-nlb cluster node. Note that most PowerShell commandlets will not end in a plural noun, even though this commandlet is able to retrieve a list of multiple nodes that are part of that environment. Nonetheless, the command is get-nlb cluster node. And we can see that I've got server 2, server 3. They have host IDs, that priority number that we've discussed in the past. Next logical thing that I want to do is start administering the port rules that identify how this particular cluster manages its incoming traffic. So, can I see port rules using PowerShell? Well, yes, of course I can. There's a command for that. What does it look like? Well, let me do a get-command, -module, network load balancing cluster, and I see that there are port rule related statements. Add NLB cluster port rule, get NLB cluster port rule, set, remove. Neat. Let's go get cluster port rules and see what we can see. And I'm going to use the information about the NLB cluster as a starting point to go get rules in that cluster. Tab completion is wonderful. And I can see I've got one port rule. It's enabled. It supports all incoming IP addresses. It covers all ports from 0 to 65535. Using multiple server filtering, using single affinity, looks good. Can I change it? What if I want to rule out my clusters handling any ports outside of the well-known ports range? I want to say anything that's port 1025 and higher, my cluster is not even touching that. Well, I would need to change the state there to be able to do, or change the mode to disabled. To disable support for that range of addresses, I would need to change the starting port number to 1025. Can I do that in PowerShell? Sure I can. How exactly? Well, it might be worth double checking the documentation on that. So I could ask for help on setting NLB cluster port rules. I can see that I can invoke set-NLB cluster port rule, identifying which port I want to apply it to, on which host I want to make the change take effect, likewise with the interface name. I can specify a new affinity value, a new end port, down here a new start port. I can change the mode, I can change which protocol is being filtered on, TCP or UDP. In this case, all I really want to do is I want to change the start port from 0 to 1025, and I want to change the mode to disabled. So I could just call set-NLB cluster port rule and start doing that, or we can see that there is a version of set-NLB cluster port rule that accepts an input object of a port rule, which is to say that if I can pipe in the identity of the rule that I want to change, I don't need to supply all the other details about it. We saw that I was able to get, at present, my only NLB cluster port rule from the cluster. I can take that and pipe it to set-NLB cluster port rule. In which case, I want to set a new start port of 1025. I want to set a new mode, and again, I can tab through these. Isn't that neat? Love PowerShell 3. There we go. We've configured that change. Let's verify in the GUI that that took place the way that we expected it to. Now, I did a quick refresh here, and one interesting note that deserves your attention. It's complaining here that host 2 is misconfigured. Now, you'll note that I made my change on host 2. I connected to server 2 to get the data, and I got an NLB cluster port rule based upon that, and then I kicked off my change. Ultimately, this was all done through the help of server 2. Temporarily, the NLB software says, hey, there's a misconfiguration here. There's a lack of synchronization. There's a mismatch between what server 2 is configured to do and what server 3 is configured to do. And temporarily, it's complaining that interface is misconfigured. It says, hey, the start port on port rule 1 is different from the rest of the cluster. That, of course, immediately is then synchronized and converged across the rest of the cluster. A second refresh confirms that everything is just fine. So sometimes 2 presses of the refresh key necessary to confirm that everything is the way that you expect. You press it twice and things still haven't stabilized, now you might have a concern. So in this case, that works just fine. Now let's go verify that we have successfully disabled our main port rule. It's disabled. Starts at port 1025. That looks right to me. So what if we wanted to create our own new port rule from scratch? Let me clear my screen and we'll take it from the top there again. So we've seen how to turn off the unwanted ports in my system by creating a rule that excludes them. What if I want to add the rule that handles the traffic that I actually do want to manage? Well, there's a command for that. Add -nlb cluster port rule. That is going to be used to be able to create the new rule and assign it to my cluster. How do we use it? Well, the easiest way to be able to ask is to ask for help. Help, add-nlb cluster port rule, gives us a description of which options we can supply, a start port and end port, what affinity we want to use, which host we're going to apply the command to, which interface on that cluster we want to be able to use to make our configuration change, which IP addresses are going to be relevant for, which filtering mode for that particular rule, all of our good friends. Now note once again, this command can take an input object of a cluster. That input object parameter is going to be a very, very handy one as you begin your work learning how to use PowerShell. The presence of an input object parameter is an indication that that commandlet can accept pipeline input. And in this case, it can accept an input of a cluster. In a lot of cases, it's easier to get the preceding object and pipeline it into the commandlet that you want to work with, rather than to supply all the details of the parameters in the other syntax. This is one of those cases. So I'm going to go get the cluster and pipe the cluster to add-nlb cluster port rule, saying please add a port rule to this cluster. In which case I can specify the start port, the end port, the affinity, what IP address range it applies to, mode, protocol, timeout, and I'm done. I don't have to say which host I want to go get data from. I don't have to say which interface on that computer I'm connecting to. So let me do that. Get -nlb cluster. I need to specify some host to be able to go get that information from. NYC server 2 is a fine choice. And I'm going to pipe that cluster to add-nlb cluster port rule. There it is. In which I want to set a start port of 20. I've got FTP servers running over on server 2 and server 3. So my start port is going to be port 20. My end port is going to be port 21. Note that correctly this parameter over here is start port. It is legitimate in PowerShell to shorten the name of a parameter down to its minimally unique set of characters. So I could have gotten away with just saying -start. That would have been fine. Start port's 20, end port is 21. Let me also specify the mode for managing this. Once again, I can tab through that. Disabled, multiple, single. Let's do multiple host management, which is typically what we'll do in most cases with an NLB cluster, although occasionally I might target traffic just at a single node. I hit the enter key and off it goes, building me a cluster port rule. Note that if I hadn't supplied a description of all the parameters necessary to make this work, PowerShell would have brought that to my attention by prompting me with the name of each parameter, asking me to supply the value that goes with each. In those cases, it might not be a crazy idea to Control-C, break out of that commandlet call. Go back and read the documentation to make sure that you know what those other parameters are being used for. It's really easy to inadvertently misconfigure something through PowerShell in the same way that it's very easy to configure something. So, I've successfully created a rule. PowerShell gave me back an object that describes the NLB cluster port rule that I built. Looks good. Can I see it in the GUI? Let's go check. I'm going to right-click my cluster, pull up properties, port rules. I didn't refresh, did I? cancel, F5 refresh. Temporary misconfiguration apparently on server 2 as it notices that there is a rule in effect on 2 that wasn't on 3. F5 refresh again, everything is copacetic. Ta-da! 2 port rules. One's disabled, everything 1025 and higher. The other one, ports 20 and 21, is using multiple host distribution using single affinity. What if I want to change the weighting? What if I know that one of my servers is much more capable than the other, maybe twice as powerful? I want to adjust the weighting of FTP traffic across those 2 servers to deliberately target one versus the other. Can I do that in PowerShell? Well, yeah, of course I can. How do I go about doing it? Well, I'm not sure which command that is. And if I'm not, I go to the help file. But in order to find the help file, I need to know which command that is. That's get-command again. Get a command for those commands that are part of the module, whose name is network load balancing, clusters, which is the one that lets me adjust the amount of stress applied to each of my hosts. It's this guy. Set NLB cluster port rule node weight. Node handling priority is for nodes that are using single host filtering, where that particular kind of traffic goes to a particular computer, not to multiple computers. If I got multiple computers, I don't use node handling priority, where I pick which computer will get all the traffic unless it fails and then some other server gets all the traffic. Instead, I assign weights. I assign a priority factor to each of the servers that will be getting this traffic so that each of them is able to get the appropriate share of the incoming traffic. So let's apply that command. Let me go get my port rule that relates to FTP traffic. Now I could do it this way. Get-NLB cluster port rule. I do need to specify which host I want to connect to, because again, I'm not on the cluster here on server 1. I can see 2 rules there. I did get-NLB cluster port rule host name NYC server 2. I can narrow the field a bit by specifying which port is relevant. Any given port will only occur in exactly one port rule. So saying show me the rule that has port 21 in it cuts it down to just that one rule. Alright, sounds good. I want to be able to tell host 2 that when it processes port 21 that it's going to do so using a different node priority weight than other nodes in the cluster. Maybe server 2 is half as powerful as server 3. Server 3 is the big beefy server. So what I'm going to do is I'm going to get this port rule. I'm going to pipe it to set-NLB cluster port rule node weight and tell it that I want it to use a node weight. The parameter name is load weight. How would I know? Help file. Set-NLB cluster port rule node weight dash load weight, and let's say 25. Very good, that looks great. Let me do the same thing for host 3, assigning it perhaps a load weight of 50. We know perhaps that server 3 is twice as capable as server 2 is when it comes to handling FTP traffic. It's got more CPU power, it's got more RAM, something, whatever. It's got faster hard drives, whatever the case might be. So I want to throw twice as much traffic at server 3 than I do at server 2. Now, not being absolute by saying how much traffic that is, number of requests or total bandwidth being consumed, just twice as much, roughly. And the NLB algorithm will deliberately reconfigure itself to try to bias towards throwing a greater percentage, approximately twice the traffic, at server 3 that it throws at server 2. 30 requests comes in, 20 go to server 3, 10 goes to server 2. Something along those lines. Can I confirm that in the GUI? Sure. Server 2 has a port rule for FTP that uses a load weight of 25. Meanwhile, server 3 is using a node weight of 50. Just exactly what I would have expected. That's marvelous. I can perform with PowerShell all of the administration tasks that would otherwise require effort on the graphical interface. So that means if the boss comes by and says, hey, it's taken too long to be able to create and tear down and rebuild our network load balancing cluster environments, what can we do in order to make that faster? You can say, well, you know what I could do is I could write a PowerShell script for that. I can tie together all the tasks of building a cluster, adding nodes, creating port rules, changing the priority on those port rules. I can start and stop nodes, I can drain connections, and I can do all of that in a 10-line, 20-line PowerShell script. Now, maybe a little bit more if you add in some documentation, some error handling, things of that sort. But consider the nifty ability to be able to automate a number of tasks that formerly required tedious tinkering in the GUI. I can now build those tasks into a script scheduled to run every third Thursday at 2 in the afternoon, or whenever I might need it to run. I invite you to look for PowerShell capability in not only network load balancing, but also lots of other features of Windows Server 2012 that you intend to be using. It'll be helpful to you in lots and lots of different areas. Thanks for being part of the lesson on PowerShell integration with network load balancing. I look forward to sharing with you more in the next lesson.